Alrighty, so we're going to try to give you the light subject at the end, since you're already sleepy. But maybe the subject is not light, but it's a relatively short talk at least. I think the record is 17 minutes, so we're not trying to beat it, but we're not going to bore you too much. It's nice to be back in New York. For me, it's especially special. The first time I spoke publicly about Ceph in my career was 8 years ago in New York. The last time I came out to see Matt's team was the last trip I did before the shutdown. So it feels nice to be restarting here. So I have been fortunate to spend nearly all my career in open source. And like almost everybody, I have had terrible marketing managers, but I also had 2 excellent ones. And one of them gave me this lesson that I will never forget, which is marketing malpractice, not to introduce yourself. So that's me in one slide. Those are things I worked on. Ceph, obviously, is the big one. Before that, I was the product person for Ubuntu Server. And before that, I was the systems management czar at SUSE, and a bunch of other things like the maintainer of man and so on. Anyway, the reason why the picture there is me all surrounded in clouds is that I have written a book on that by O'Reilly. And I am joined by Sage.
Hey everyone, I'm Sage McTaggart. I use they, them pronouns, and I work on cybersecurity for Ceph at IBM. I did my undergrad at UMass Amherst and graduate school at UC Santa Cruz. I've done research in a wide variety of areas, ranging from programming languages, file systems, all sorts of other stuff. And I was working on security for Ceph and ODF at Red Hat as well. I love formal methods. I love all sorts of different parts of security. And in my free time, I love to hike with my dog and garden and work towards a more inclusive world. And that's my dog right there. Her name's Aurora, and she's an absolute wonderful dog.
So we both successfully escaped from academia, except I still have a taste for corduroy, apparently. There are slides introducing Ceph and Rook that we're going to jump over. They're built for a different audience. Those became clearly not applicable when someone asked the question about the AIX client. So let's jump straight into security. So the big picture for security is that security practices harden a specific point of the infrastructure. Cherry-picking practices without a model of the threat and of the attacker is just not a viable strategy. The joke usually goes that to really secure a computer, you have to cover it in concrete, shut it down, throw it to the bottom of the ocean, but then it's not very useful. And so in other words, in practical words, absolute security is not usable or maybe even attainable. So you have to define a threat model. Are you facing script kiddies or the GRU or the dreaded privilege insider? These are very different scenarios. Some of these want to steal your data, others want to cryptolock data and hold you for ransom, others just may be satisfied with deleting things at random, and the disruption that causes, like a transient denial of service kind of thing. You need to define what threats are, what threats and personas you're protecting against and what is the priority so that you can pick your battles. If everything is a priority, then nothing is. So let's dive right in from the network side. The public security zone is an entirely untrusted area of the cloud. It could be the internet as a whole or just networks external to your cluster that you have no authority over. Data transmissions crossing this zone should make use of encryption. Note that the public zone, as I just defined it, does not include the storage cluster front end, the Ceph public _ network, which sounds the same but is not the same, which defines the storage front end and properly belongs in the storage access zone. Now, going down the list, The Ceph client zone refers to networks accessing Ceph clients, like the object gateway, the Ceph file system, or block storage. Ceph clients are not always excluded from the public security zone. For instance, canonical example would be to expose the object gateways S3 or Swift APIs in the public security zone so that data can be retrieved from the outside. Next on the list, the storage access zone is instead an internal network, providing Ceph clients with access to the storage cluster itself. Finally, the cluster zone refers to the most internal network, providing storage nodes with connectivity for replication, heartbeat, backfill, and the like, recovery. This zone includes the Ceph cluster's backend network, called the cluster network in Ceph. Operators often run clear text traffic in the cluster zone, relying on the physical separation or VLAN separation of the network from all other traffic. This, going back to the previous example, would not be a valid choice if your threat model includes adversarial privileged insiders, for example. These four zones are separately mapped on or combined depending on your use case and the threat model you use. And so you have things like these, where you can look at what services you have and what networks they span to. Now, at the edges of these connections, you have components spanning the boundaries of two networks. And by definition, because they're spanning the two zones with different levels of privilege, you need to secure them with the requirements of the highest privilege network. These are the natural, I wouldn't say weak points, but they are the natural points to attack. If you know that, that a daemon has access to the network that you are in and to the network that you want to attack, you're going to try to find a vulnerability in that daemon to cross over. In many cases, the obvious thing to look at is the security controls. Like, are things properly secured? Is there an obvious misconfiguration that was missed? If possible, exceeding security requirements at integration points is a good idea, which, given that this is a storage product, is easier than it would be on a generic operating system or a compute product. For example, it's very easy to look at the cluster security zone and have it isolated from other zones because there is no reason to connect to almost anything else. It's just internal replication traffic. Completely the opposite could be an example again with object gateway. It needs to access all the nodes and all the OSD nodes to get at the data, needs to access the monitors to know where the cluster map is, and will likely need to access the outside to serve data out. So we have all varieties in terms of the daemons that we have, but we don't have to apply the most permissive policy to everything. Sage?
Yeah, so let's talk a little bit about product security and what we do to ensure the security of Ceph. I'm going to go a little bit light on the details with the move to IBM since we're still hashing out some of the specifics, and I don't want to say something and then we change it. But in general, we're getting everything working, and I'll be explaining it at sort of a high level. So product security at IBM follows a secure development lifecycle with the goal of reducing risk and improving security for Ceph. We always are suggesting improvements. We're pen testing more regularly now. We're manifesting all of our dependencies, just like at Red Hat. We're reviewing vulnerabilities, tracking weaknesses, exploits, all that good stuff. We'll still be doing security releases and reviewing all new releases just as before, checking everything for CVEs and vulnerabilities just like before. Except now we're at IBM and using their systems. Previously at Red Hat, this was split into two different roles of incident response and security architect, which you might have seen in prior versions of this talk. And now it's a little bit different. So we're going to continue, just like I said, everything else that we did before. We're onboarding with IBM PCert, and we're going to update you more with more information in the future about how exactly that looks. And in addition, we're going to continue to expand our process to improve code security preemptively and eventually start following IBM standards to fix vulnerabilities and ensure compliance. And these are oftentimes even more extensive than Red Hat's. So in addition to us still being devoted to upstream everything else, all of this will result in a more secure Ceph because we have even more rigorous requirements as we have 3 releases going on. And again, just to reassure everybody, all of these CVE fixes get ported to upstream. We're still going to keep all versions of Ceph equally secure. Now, of course, new collaboration produces new challenges and lots of really fun and clever goals that we're still figuring out how it's going to play out. But fingers crossed, it works out fantastic. And please feel free to reach out with any things, any concerns that you have, any collaborations with IBM that you want to talk about, like all of this stuff, please reach out. I know a little bit later on the details as to what we're doing for vulnerability response than before, but it's looking like it'll be even more secure than in the past, and you know, it'll just continue to improve and improve with this collaboration, and that will help the open source version, upstream, everything just be more and more secure as time goes on. Everything's still in flux, but it will be better. So let's now talk a little bit how Ceph actually implements encryption, not just what happens when we get a vulnerability report. So server side, the operators overwhelmingly choose to encrypt data at rest using LUKS. And you don't necessarily have to have encryption, but it's an option that we highly, highly recommend. All the data and metadata of a Ceph storage cluster as a result of using LUKS can be secured using a variety of DMCrypt configurations, and almost all of our customers choose to. You should choose to do this. We enable a general security best practice by locating our monitors on separate hosts from the OSDs. We ensure anti-affinity of the keys and the data that they encrypt. This means that your driver host is physically separated from your decryption key as much as possible, so that if somebody steals one drive, they don't have both the key and the data. They either have one or the other, and that makes it a little bit harder to crack. The Object Storage Gateway also has some additional encryption capabilities. It includes encryption at ingestion time. We have the use of per user keys as opposed to just pure per drive keys. So, you know, if you want to revoke a user, you don't have to re-encrypt everything and send out a whole new key. We allow key rotation with tools like Vault. We have support for AWS, SSE, KMS, and more key management systems. In addition, we have FIPS 142 standard ciphers as certified by the Department of Defense, and that can allow a FIPS 140 mode when you're using RHEL in an appropriate version as your base. Now, what about encryption in transit, now that we've covered encryption in rest? Well, network communication can be secured by turning on the Ceph protocol with the messenger version 2.1. That was introduced with Nautilus. Now, clear text is fine in this case. It's not a huge security risk because typically where you have a network where you're using the Ceph protocol, it's physically or logically isolated from access. You aren't just having people monitoring it on the wire. You aren't just having people sniffing your packets. It is a little bit of concern if you're on the cloud in a shared cluster, perhaps with a Kubernetes deployment, or if you run a little bit more nervous about security, or you want to, for whatever reason, have encryption on the wire here, and your threat model includes it. Thus, we implemented encryption here. And, you know, there's a lot of issues with compatibility and overhead for backend protocols. So it really depends on how you're setting up your network, how you're setting up your deployment. But that being said, in most cases, the performance impact is pretty insignificant for a properly designed cluster. Your latency is going to be completely overshadowed by network communication as long as you account for your CPU overhead. And, you know, we have some best practices here that go back to the security zones that we were talking about. You have your network hygiene. You generally want to have these in addition. So when we think about some more specific protocols, though, S3 service is usually secured between RGW and the S3 client. We use TLS on port 443. You can totally use plain HTTP on port 80, depending on the nature of your data being served. If you want to make it public, you can, but it's usually secured, and we recommend that. TLS termination at our HA proxy is a special case. The link between HA proxy and RGW is clear text and needs to be located and protected by the security zones that we were just talking about. And of course, with the network, standard security practices like firing individual nodes to only expose to cleared list of ports apply. We check that with pen testing. We're making sure that everything is generally pretty safe. But those are all best practices. And, you know, Rook specific isn't quite as relevant here, but Rook can use CRDs to encode many of these settings, configuring trust certificates for our RGW web server. Rook also supports at-rest data encryption, as we discussed earlier. In-flight Ceph protocol in 1.9 Kubernetes permission system also applies to the persistent volumes. So you get the permissions, quotas, and all that comes from Kubernetes. Nothing Rook needs to do here. Rook supports a key management system in the CSI driver, container storage interface, and that allows, again, individual volumes to be encrypted with their own key. Going back to that limits the scope per key, so if you need to revoke a user, you can. And this is all done so that we can follow best practices easily. Key rotation, revocation, limiting the scope from each key. It limits the scope of our unencrypted traffic, and all that good stuff. Best practices, important to follow. We all see them on paper, but we got to make them easy to implement. So that's stuff that we're doing. And talking about the control plane as well, it's popularized by Ansible. SSH is used by Ceph admin, Ceph Ansible, all other sorts of deployment and day one tools to provide a secure command path for install and upgrade operations as part of host management. We don't necessarily want our dashboard to be exposed to the world, but it does definitely need to be reachable by your operator's workstation to be of use. So the manager supports the whole infrastructure, has to be reachable on the storage access zone. So how do we do that with our control zones? Our control planes, SSH. So yeah, but who are we and who is accessing what? We sort of have to talk about identity and access briefly. And we do use shared secret keys. That protects us from man-in-the-middle attacks by default. Shared secret keys are done using AES, which is thought to be quantum resistant. Fun fact. But you still need to do some good practices. You have to grant keyring read and write permissions only for the current user and root. You want your client admin user restricted to root only. You don't want all users to be root. That's a bad security practice. Don't do that. And, you know, talking about RGW next, it supports the key and secret model of AWS S3, the equivalent model for OpenStack Swift as well. And talking a little bit more about RGW again, the administrator's key and secret has to be treated, well, also in general, the administrator's key and secret should be treated with appropriate respect. You don't want to reiterate the point, you want to use your administrative users sparingly to reduce your risk profile. The RGW user data is stored in Ceph pools, which should be secured as we discussed previously regarding data at rest. This isn't required, but people generally do use it. We can couple with OIDC providers such as Keycloak, backed with your organizational IDP for an even more granular role or attribute access, but we'll continue to work to make this more and more granular as time goes on, just to make security best practices even easier. And again, we support LDAP and Active Directory users. We highly recommend using secure LDAP. We support OpenStack Keystone to authenticate Object Gateway users and OpenStack clouds. These are all some practices that you can use here. And to talk briefly about auditing, what happens when there is a breach? How do we detect it? What happens when we want to just check our logs? What happens if we have a security requirement that requires audits? Well, we allow operator actions against a cluster to be logged, and they're stored in var log Ceph audit log. You can check the information there. You definitely want to periodically remove them so that if somebody gets your cluster, they can't necessarily see all your prior logs. And you want to aggregate them to your log management system as appropriate for security scans, auditing, all that other stuff. So on that note, I'm going to let Federico finish up talking about data retention.
Thank you. So one more. Once data is deleted from a Ceph cluster, it generally cannot be recovered for practical use. But there are exceptions. RBD has a new facility called the trash bin, where you can make dynamic use of spare pool capacity to retain deleted images until that capacity is needed, or until a certain number of days has elapsed. Similarly, in RGW, versioning of object store buckets may result in deleted objects being preserved in the history, in the versioning, until they are purged either by a policy or by the operator deleting them. So whenever user data retention is a concern, you want to configure your storage pools so that you get the behavior that you want. And don't just go for the defaults if user data is involved. Additionally, individual data blocks that used to constitute an object, file, or volume are often still present on persistent storage, like with any type of storage, really, until they're overwritten by that capacity being used. So you can, and in the case of Ceph, you cannot securely delete a cluster by writing a ton of data to it. It's not going to work, or this is not going to work reliably, which is what you care about. Secure deletion is another common question. So the easiest way to solve this is to do the right thing from the beginning, which is, again, encrypt the data at rest. And when you want to sanitize the disk, you forget the encryption key. Throw away the encryption key, and that's it. Plus, there are plenty of storage media these days that provide that functionality in hardware, so you don't even have to manage it. And when you need to sanitize, okay, so besides the case when you need to sanitize the media, there are two other cases. You need to sanitize the media in a way that can be used for RMA, like your drives failed, you need to return them for warranty replacements. You cannot use a shredder or a degosser usually in those cases. You cannot return destroyed drives for warranty unless you have a special contract with the vendor. So that's another reason to use encryption keys instead. And then the other case is when you actually want to prevent deletion, absolutely the opposite scenario. And so there, Ceph is one facility which is the use of multi-factor authentication in RGW, so that you can make it harder for someone to go and delete your data in an attack by requesting a second factor. There is one more thing, which is hardening options. So these are very highly vendor dependent, but they're really the availability of them is all the same across all Linux distributions. The question is whether they are compiled in the kernel, or in the case of the Ceph distribution, if the binaries are compiled with it. So these are Red Hat's choices. Other Ceph distributions may vary. We ship with SE Linux by default in Red Hat, and we will do the same at IBM. And that's hardly a surprise, given that SE Linux is sort of a religion at Red Hat. As Sage mentioned, we can make use of FIPS 142 optionally. You configure the operating system for that. Red Hat Ceph Linux, Ceph storage binaries are compiled with those options, and we don't want to go into a discussion of GCC. I think that we're dense enough already. But those are the ones that we're using. They generally get in the way of exploits that are buffer overruns or heap overruns. On the kernel side, obviously you get the options that RHEL selects, but you can always build your own kernel and play with things like SIGCOMP, Pi, and the like, or the ASLR options, although quite a few of those are already in RHEL by default. Generally, what you want to do as the user is consult your vendor's documentation and just figure out what that is already in there. And most of us don't have the time to do garage experiment and build your own kernel, build your own Ceph distribution, build your own application. But we should have the time to look at what hardening is being done at the levels that we got from somebody else. These binaries, going back to the original point, sit at the intersection of the safer to weaker security zones, so anything that we can do to harden them helps our case. So that is it, aside from some bookmarks for you, explaining the things that we didn't go into. So managing Kubernetes secrets is always a favorite. Rani Osnat at Acquia has written a very nice primer on that. Chapter 6 of Hacking Kubernetes, Michael Hasenblatt's new book, has a very nice primer on storage that is primarily Kubernetes-based. A data security and hardening guide is coming from our product. It's part of the of the Red Hat and IBM Ceph storage product, but it's a nice primer, and it expands on what is in this deck essentially. The Kubernetes core documentation has very nice details on how to encrypt secret data at rest, which kind of goes back to Rani's article at the beginning. And then the last item is for all the stuff that we didn't discuss about hardening the kernel or the binaries. That will explain all the mystery flags of GCC for those of you that are fortunate enough not to know them. And there is another one that's not here, but the Ubuntu security team has a very nice table of the hardening options of the kernel. So you go to their table, and if you're not a kernel security expert, you know what they are, and then you can Google them for your own distribution. And I think that's it. Let's see if there are any questions. These are all the people that have contributed to the presentation so far. If you have things that we should be adding here, areas that we didn't address, or suggestions, complaints. Alex, not AIX.
Block level exfiltration scenario of a hyperconverged OSD and monitor node, containerized. Is there a theoretical possibility that the attacker can decrypt the OSD data?
Decrypt the OSD, having what?
So OSDs have been encrypted with LUKS, right? So de-encrypt from the beginning. However, monitors store the keys.
Yes.
I don't know how they store them. I know they store them.
Ah, okay. Yes, now, that's a very smart question.
You got a hyper-converged...
Hang on, before you make it more complicated, because this is the limit of what people can take already. The OSD is being encrypted with LUX. Where is the key? The key is in the monitor. So that goes back to what Sage was saying earlier, that we want anti-affinity between the monitor and the OSD so that the key is somewhere else. So that you have to steal 2 machines at least. Then, the key is on the monitor machine. So how is it secured on the monitor machine is the part of the question that I get from the smartest people like you. So the answer there is that you're also de-encrypting the file system of the monitor so that that key is encrypted at rest on the monitor. That's usually the full...
And what's the key for the key?
The full thing. The key for the key is there on the machine. So if they can boot that machine, then you have lost the game.
So what if it's a container?
It shouldn't matter. You still need to boot the host.
Okay.
And I just want to say with that, when you ask a question like, is it theoretically possible? Everything can theoretically possibly be hacked.
Yeah, but no.
Yeah, but there's realistic.
You are showing that you're from the DC area because that's where usually these questions come from.
Up until a couple of years ago, we didn't think that the predictive, power analysis was possible in the certain CPUs, which are all CPUs. But now we know. So.
Yeah.
We have gotten that question from several 3-letter agencies, of which IBM is not one. So that is a very good question.
Okay.
Yes.
I have a similar question. If you use the encryption in the Ceph CSI, where the password is stored in the storage class, and the key is stored as the metadata next to the image, and from my understanding, is it like this: if all the images, I have 1,000, 10,000 images with the keys, and the key is always encrypted with the same passphrase, it should be possible to reverse engineer this passphrase.
Oh, you're saying in terms of doing a large number of known ciphertext analysis?
Yeah.
I don't know. That's a good question about how can you attack LUX and how much ciphertext you need to attack LUX. Yeah,
I mean, you mentioned that you normally try to separate the keys from the data, and at the moment we made already the decision to re-implement this part of Ceph CSI because in the storage class, the passphrase to encrypt the key of the image should not be stored, so that we do it like in a vault or.
Usually, the answer there is. Either A, the protocol uses temporary keys, and so you don't care as long as the sessions are not very long-lived. Or 2, the protocol doesn't use temporary keys, in which case you need key rotation. Like Amazon keeps bothering you saying, rotate your keys every, I think, 3 months, are they now? But I don't know what scenario would LUX fall into here.
I think it's not the problem of LUX. It's just that it is implemented in Ceph CSI with an additional passphrase to encrypt the key. It's nothing related to LUX.
Oh, you're saying
it's just on top, because they did not store the key in the monitor database. They just added as a metadata information to the RBD image, and then before they added, they encrypted with a passphrase that is stored in the Ceph CSI storage class.
Okay, I'll have to look into that.
Yeah,
I don't know.
Okay.
Great question.
Thank you.
Hey, so we actually started encrypting with LUX before Ceph was doing it, I think. So this maybe is a dumb question, but is there a facility to rotate LUX keys, like built into Ceph with like?
Oh, definitely not built into Ceph.
Okay.
So anything that's available for Linux we could use, but we don't have our own.
Okay.
And the most popular thing in terms of key rotation, usually Uday and I get the question about object stores. And the vast majority of customers that want to do that use HashiCorp Vault.
Yeah.
But obviously it's at another level.
Okay.
All right, going once, going twice. Thank you.